Today we are talking about rhombuses, rectangles, and squares. Rhombuses, rectangles, and squares. Oh my.
Isn't it?
I handed them out. There's two sheets and I didn't staple them. Everybody else have them? Your notes? Alright, a rectangle. Rectangle is a parallelogram. Everything we're talking about today is a rectangle. Rectangles, rectangles, rhombuses, or rhombi, and squares are all parallelograms. Okay? A rectangle is a parallelogram, so it means it has all the properties that we talked about a parallelogram having, plus it has four right angles. We knew this. There's all the qualities that we learned about last week for a parallelogram. And in addition, we know that all four angles are a right angle. We kind of mentioned that, I think, when we did our first day of parallelograms, because one of the things we said is if one angle is a right angle, then all four are right angles, right? And we mentioned that that would be a rectangle. A rhombus. You do not see four right angles there, right? But you do see that all four sides are congruent. So it's a parallelogram as well. Does not necessarily have four right angles, or it does not have four right angles, but it does have all four congruent sides and all the other properties of a parallelogram. Did you write that? And it was rectangles, rhombus, and square. Rectangle, rhombus, and square. So a square, you'll see marked on the diagram, all four right angles and all four sides are congruent. We knew that. You may not have known that it was a parallelogram, but you knew that it had four congruent sides and four right angles. Now you know it's a parallelogram. Since a square is four right angles, a square is a rectangle. Since a square has four congruent sides, a square is a rhombus. But not all rectangles are squares, right? And not all rhombuses are squares. All right. So now you see the list of the properties of a rectangle, but you'll see on the right here, and I want you to highlight this part, these first five are common to all parallelograms. So these first five are going to be common to rectangles, rhombuses, and squares. Right? So we're going to go ahead and highlight that bracket there with your pencil or a highlighter or something. These properties are common to all of the figures we're talking about today. The two that are unique to a rectangle, the diagonals of a rectangle are congruent. And all four angles are 90 degrees. So you can also mark you get the gist. First parallelogram. Jason, did you need me to go back? Can you see? Where are you back? So, a rhombus has the same five properties as all parallelograms. Opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles are supplementary, and the diagonals bisect each other. So the properties that are unique to a rhombus, this one is new. The diagonals are perpendicular. What does it mean when segments or lines are perpendicular? Very good. They form right angles. So let's make ourselves a note. So right angles, right? So they make right angles where they intersect. So there's 4 right angles where the diagonals intersect in a rhombus. The diagonals bisect a pair of opposite angles. And all 4 sides are congruent. You guys caught up with me? Okay, hold good. Square, same 5 properties. I'll highlight that again. And then the properties that are unique to a square. So a square has all the properties you'll see of a rectangle and a rhombus. The diagonals are congruent. All 4 angles are 90 degrees. Those are the 2 that are unique to rectangles, and a square is a rectangle. All squares are rectangles, so all squares have these common properties of rectangles. The diagonals are perpendicular, just like in a rhombus, because squares are rhombuses or rhombi. Just like in a rhombus, diagonals bisect a pair of opposite angles. And finally, all 4 sides are congruent. So we don't have the word square over there, but all of these properties are properties of a square. All the properties of a rectangle and all the properties of rhombus. If it's true of a rectangle, it's true of a square. If it's true of a rhombus, it's true of a square. There's a little nesting box underneath that. I don't know if you guys remember, but probably when you were in middle school, you used a Venn diagram when you learned about rational and irrational numbers and real numbers. Irrational and rational numbers. All irrational and irrational numbers are real numbers, but rational numbers have integers, whole numbers, natural numbers, and then numbers we can only call rational. That would be numbers that have repeating decimals, any number that can be written as a fraction, right? And we would typically learn that how to write that in a Venn diagram. That's what this one is. So this Venn diagram is like a nesting box of rectangles. So for the first big rectangle, all of the figures we're learning about are quadrilaterals, right? All the figures we're learning about are parallelograms. There are other quadrilaterals that we have not talked about today, or yet. A trapezoid is a quadrilateral, but we have not learned about the properties of a trapezoid yet. We have learned about the properties of parallelograms, though. So everything in the whole big rectangle is a quadrilateral. Everything that falls in within the next biggest rectangle, these are all parallelograms. The next rectangle includes all rectangles. So all rectangles are going to include all squares. So this rectangle is the squares. All squares are rectangles. And all rhombi are in the last rectangle. I knew you wouldn't believe me though, so I didn't try to argue with you at first. Or I didn't try to convince you. Not argue. I knew we would never argue patience. Alright. Y'all caught up? Alright. It's example 1. So they're telling us it's a parallelogram. So we have to tell them, is it a rhombus, a rectangle, or a square? We have to tell them based on how that figure is marked. So based on only the way that this figure is marked and the fact that they told us a parallelogram, what would we say example 1 is? A rhombus. All 4 sides are congruent, but we see nothing about right angles, right? Good job. Now looking at example 2, what do they tell us? What do the marks tell us? It is a square. We know it's a square because all 4 angles are right angles and all 4 sides are congruent, right? So it is also a rhombus, right? But we need to give the most specific answer, right? So if you told me rhombus here, I would not give you credit for it because I need you to be more specific. So what kind of figure, what kind of parallelogram is example 3? Rectangle. Opposite sides are congruent and 4 right angles. And what about example 4? I only see 1 right angle. 1 pair of sides is marked congruent and that same pair of sides is marked parallel. It's just a rectangle. That's right. So we learned on Friday, I believe, that, well, number 1, they're telling us this is a parallelogram, but we learned a new way to determine if a quadrilateral is a parallelogram. If they give us a pair of sides and tell us they're congruent and tell us that same pair of sides is also parallel, now we know it's a parallelogram. And one of the properties of a parallelogram is if 1 angle is a right angle, then all 4 are right angles. So that means you guys are correct, that is a rectangle. Alrighty. Quadrilateral, FGHJ, is a rhombus. So we have to think about the properties that are specific to a rhombus. So I have written some of them out here for you. The first one I want to remind you of is that the diagonals in a rhombus are perpendicular. So what do we say it means if the rhombus or the diagonals are perpendicular? So now we know that all 4 of these angles, right, are right angles. If this one is a right angle, that makes them all right angles, right? Because this is supplementary to this is supplementary to that. So I'm just going to put 1 right angle. That means, that's how we know that those diagonals are perpendicular. Well, and because they told us it's a rhombus, but now we've marked our figure that way. We also know that a rhombus, all 4 sides of a rhombus are what? Congruent. So now we know that let's go ahead and mark all 4 sides congruent. Something else that will be helpful for these examples is the diagonals bisect a pair of opposite angles. That means that this angle's congruent to this angle, right? Opposite angles are congruent, so that's gonna make those two congruent as well, but I'm just gonna mark those two, because that's the only one that has a measure there. Alright, we've got enough to get started now. So example 5, we're gonna find the measure of angle 1. What is the measure of angle 1? We already know this.
90 degrees.
Yes, remember that's 90, they're all for 90, because the diagonals are perpendicular. So let's go ahead and mark a 90 in there. If this is 90, then this is 41. The next example, we need to find the measure of angle 2. But we know that the diagonal, this diagonal FH bisects this angle, so that means that angle 2 and angle 1 are going to be congruent, right? So we've got to figure out what that is. What'd you say, Patience? Is it 92? Nope. Only these central angles where they are where the diagonals intersect are necessarily 90 degrees. Alright, but we can find the measure of this angle. Now we know that it's congruent to that angle by doing what? We know this angle is 41, this angle is 90. So how can I find the other angle, Gregory? Perfect. 90 plus 41 is 131, so we're going to do 180 minus 131, and that equals 49. And since that's 49, now we know the measure of angle 2 is 49. Any questions on that? All right, what's the measure of angle 3? Anybody know? What's the measure of angle 3, or how can we find it? Jed says it's 49. What'd you say? Why is it 49, Jed? Ah, that's right. Remember last week we used alternate interior angles because these sides of this quadrilateral, this parallelogram are parallel by definition. That makes the diagonal or transversal. That makes the alternate interior angles congruent. So if angle 2 is 49, then angle 3 is also 49. So we can mark that one congruent. The measure of angle 4. What do you think the measure of angle 4 is? Zariah, can you tell me what the measure of angle 4 is? Angle 4 is right here. What do you think, Hannah? Can you help her? Aren't 4 and this angle that measures 41 also alternate interior angles? It is 41, right? You gotta look for those alternate interior angles. So that one is also 41. So this one is congruent to this one and this one, right? Alright, now KJ. I want to make this a little bit bigger.
This is Simmons.
Yeah?
He sent Bailey to attend that she will return.
Okay. So we want to know what is the measure of KJ. What is the length of KJ? And that is this section right here. It's not an angle, right? It's a side measure. So it's half of the diagonal. So we know, sorry? No? Not half of the angle. This is a length of a side, right? So the 45 would be half of the 90-degree angle. KJ is this length from where those diagonals intersect to angle J, right here. So this length. So I'm going to go ahead and give you a hint. We're going to use the Pythagorean theorem. Remember what the Pythagorean theorem is? Okay. So the Pythagorean theorem is something we learned about that only works for right triangles. But we know if you square each of the legs of a right triangle, and you do have to remember what the legs are, they will equal to the square of the hypotenuse. So that formula is a squared plus b squared equals c squared, where a and b are the legs. So a and b are the legs, so the one leg squared plus one leg squared equals the hypotenuse squared. So if we know one leg and the hypotenuse, we can solve for the other leg. If we know the two legs, we can solve for the length of the hypotenuse. So looking back at our diagram, what do we know? Do we know the length of the hypotenuse? So remember, the hypotenuse is the side across from the 90-degree angle. Do we know how long that is? It's 13, right? This side is 13, so this side is 13. Alright? Now, do we know, so this is what we want to know. We need the other leg length then. Do we know how long KH is? How do you know it's 5, Jen? Yes. KH is congruent to KF because that diagonal was bisected by the other diagonal. So now we know this leg is 5. So I'm going to draw a little bigger version of that triangle down here. It'll look similar to the triangle in our diagram. That's our right angle. That's 5. That's 13. This is what we don't know. So now we're going to plug into the Pythagorean theorem. So we're going to call, we can call the leg we don't know A. So a squared plus, remember the legs are the sides that form the right angle, plus 5 squared equals the hypotenuse squared. So a squared, bless you, plus 25 equals 169. If I subtract 25 from both sides, I have a squared equals 144. And this is where you use the square root button on your calculator. On our calculators, you can put 144 in and then hit the square root button. Remember that there's a positive and negative square root of 144, but we're talking about distance, so we only use the positive one. So the length of A, the length of KJ is 12. Any questions on that? FH is, we've already found what FH is. The diagonals bisect each other. We've already talked about that. But let's go ahead and make a note of that there. That's how we know that FH is 10 because, bless you, KF and KH are both 5. Together that length is 10. This diagonal bisected this one, so if this is 5, then this has to be 5, which makes the whole length of the diagonal 5 times 2, or 5 plus 5. Any questions? Alright, you guys caught up with me? Can I move on? Alright, you're going to go ahead and draw the rectangle. If they talk to you about a figure and you don't have the diagram, it's in your best interest to always draw that figure. So, rectangle ABCD, it doesn't matter which way you label those. It could have been ABCD or ABCD. It says, find the value of x and the length of each diagonal. So, let's go ahead and draw our diagonals. So AC is a diagonal. And diagonals go from the one vertex to its opposite non-consecutive vertex. Actually, just any non-consecutive vertex. In a rectangle, it's always going to be that one that we call opposite. And then BD or DB does not matter. We know this is a rectangle. What do we know about the rectangles, the diagonals of a rectangle? Look at your list of properties, what do we know about the diagonals of a rectangle? So let's go ahead and make a note. The diagonals are congruent. So now that we know that this diagonal is congruent with this diagonal, now we know this length is equal to this length. If they tell us the length of AC is 3x plus 7, and the length of BD is 5x minus 11, now we know we can set those equal to one another and solve for that variable. Once we solve for that variable, we're going to use that value and plug it back into one of the expressions to find the length of the diagonal. Remember, we only have to find the length of one diagonal because they're congruent. So go ahead and write your equation where you set those lengths equal to one another and solve for x. You get both variables on the same side first. I would subtract 3x from both sides. I'm going to do 7 equals 2x minus 11. That is what you should do. I'm going to add 11 to both sides. And 18 equals 2x. Divide both sides by 2. And now that I know that x equals 9. So that was the first part that they asked me to do. They asked me to find the value of x. Now they want to know what is the length of the diagonals. So we can plug into either 3x plus 7 or 5x minus 11. I know that AC equals BD, and they both equal 3 times 9 plus 7. So they equal 34. And same thing with example 12. They gave you a different expression to represent the length of each diagonal. In that example, they tell you that AC is x equals x and BD equals 4x minus 12. You still just set them equal to one another and solve for the x. We subtract x from both sides. Add 12 to both sides. Divide both sides by 3. And now I know that x equals 4. Well, diagonal AC equals x. So now we know that AC equals BD, and they both equal 4. Any questions? We have another example? That's it? We're done? Woohoo! You have time to start your homework and scan and submit your notes first, and then start your homework. Once you scan and submit, make sure you drop your phone back down in your backpack. Remember, not in your lap, not in your pocket, not on your desk. But you can scan and submit because I'm here.